What inspired you to join the ELLIS Unit Jena, and how does this align with your personal research interests?
My group's research is in the field of modeling Earth surface processes and natural hazards using machine learning as well as process-based models. And in this field, the ELLIS Group Jena is a leading group of experts of both Earth system science as well as geospatial artificial intelligence, which has the potential to inspire my group's research in these application domains.
What does success look like to you personally in the context of your work at the ELLIS Unit Jena?
What is most rewarding for me is to see young researchers succeed in their research, to make a difference in using geographic information for improved decision-making in research, but also in a governmental decision-making context.
What do you do outside of work to unwind, and how does it help you approach your research with fresh perspectives?
I enjoy cross-country running and cycling and being outside in the nature. It's really not just relaxing, but it also shows you how complex nature is, how the environment is changing. And this can be motivating academically, but also reminds us of the importance of the environment and of its beauty as well.
How does the interdisciplinary nature of the ELLIS Unit Jena enhance its ability to address complex societal issues related to Earth systems?
The most pressing environmental issues that we're currently facing related to the impacts of climate change, for example, have social as well as physical environmental dimensions and require the optimal use of information and of environmental and geographic information to address these problems. So therefore, naturally, we need multiple disciplinary views and not narrow perspectives to address these challenges. The ELLIS unit provides exactly that, with domain experts from multiple Earth system sciences, as well as artificial intelligence experts that provide the necessary methodology.
What are some specific ways that the advancements in AI and machine learning from the ELLIS Unit Jena are being applied to real-world environmental challenges?
One environmental issue that we're currently investigating is the pollution of groundwater with nitrate. And here we're collaborating and are currently funded by the Federal Environmental Agency of Germany as well as a state agency in trying to make best use of the available information to designate nitrate polluted areas across Germany and to spatially map the concentration of nitrate in groundwater. So here we're starting with classical established geostatistical procedures, and in this project also advance towards artificial intelligence methodologies that are either physically constrained, trying to best represent the complex physical nature of the problem, and that combine modern approaches with established geostatistical methodologies.
What role does collaboration with external partners, such as government agencies or NGOs, play in maximizing the societal impact of the ELLIS Unit Jena's research?
Working directly with external partners, such as government agencies, is really crucial to make sure that we have a fast and effective pipeline from methodological research and geographical artificial intelligence into government decision-making and into domain sciences. So we are currently working with German Federal Environmental Agency, developing geographic artificial intelligence methods, and starting with geostatistical approaches to advance the designation and the mapping of nitrate-polluted areas across Germany using methods developed and advanced within the ELLIS Unit Jena. So without these collaborations, it would probably take one generation to pass that information through our students into the areas of professional practice of these new experts, and therefore into their application in government and industry.
What is the overarching goal of the ELLIS Unit Jena?
The overarching goal of the ELLIS Unit Jena is to improve our understanding of the Earth system and how it evolves, how it is affected by climate change. To this end, the ELLIS Unit Jena tries to leverage modern information technologies, specifically geographic artificial intelligence, to make better use of the available information, remote sensing data, environmental sensor data, but also societal information in order to understand the Earth system and help with decision making.
What are the biggest challenges in applying AI to Earth system science?
Many environmental processes and variables are very hard to observe directly. We have to make use of indirect observations, so-called proxy variables, to infer the state of the Earth system. That makes it hard to make predictions in space, but also into the future, and to infer causalities from patterns in data, which is basically our job in environmental data science. A second issue is that spatial data is special. Spatial data has spatial autocorrelation, which can create some challenges in the time of trying to find patterns in data, but it also creates potentials for making better spatial and sometimes temporal predictions using geospatial data.
What are the benefits of the interdisciplinary approach within the ELLIS Unit Jena for your research?
Complex environmental issues require multiple perspectives, and the ELLIS unit provides exactly that. We go from narrow disciplinary perspectives, each of us contributing to our own narrow research field, towards putting together these puzzle pieces to solve bigger problems. This is the main benefit of the ELLIS Unit Jena.
What is the ELLIS Unit Jena for you?
For me, the ELLIS Unit Jena is an accelerator that brings geographic artificial intelligence into science as well as policy-related applications. They offer also an accelerator for our early career scientists to do excellent research that matters for our society.